I'm Roy, and I'm in the process of taking this 2016 Polaris Ranger 6x6 and converting it to an electric vehicle using a leaf motor and battery pack. And my plan is to put the motor in here and the batteries back here, and then I'm going to drive it in this manner. We'll have the motor and differential here, so the two stub axles from the leaf will come out this way and tie into drive shafts that go to the rear axle and the middle axle and to the front axle. The top speed, because I'm using it's really going through two differentials, will be 24 miles an hour or 40 kilometers per hour. Okay, I wanted to show you what I've set up here in my shop. I wanted to test the battery and motor and everything to make sure everything worked with the Resolve EV controller the way Isaac said it would. And I'll show you that it has. So here's the battery pack with the cover removed. And to remove the cover, I suggest you read in Nissan Service Manual for 2015 on how to remove the cover, because there's a pretty tenacious rubber gasket that seals the top of the battery cover to the bottom. And I used just a vibrator cutter to cut the rubber, and that really worked well. Now, because this is real high voltage, like 340 volts DC, they have a main disconnect, which is accessed in the car on the tunnel in the rear by the rear seat. So to disconnect everything, you take off this sort of like fuse thing and take it off. But some of this might still be live because I think it just controls one part of the circuit. This is the high voltage relays, and they control, when the computer says, hey, start the motor, it sends the voltage to the inverter, and then it runs the motor. So be real careful on this high voltage, plus when you're testing this relay in here, you'll have to disconnect these bus bars so that there's no current going to them. Now over here, I want to show you the discharge of the battery. This is the BMS port, which is sort of controls the whole system, and that's all tied into the Resolve controller. This is the high voltage port that goes to the motor. It comes here, it comes right in here and goes into the charger. And this is a high voltage port that was used for the heater that heated the car in the wintertime. I don't think I'm going to use it, but for some reason you wanted 340 volts DC for something, that's a way you could tap into it easily. Now I'm going to come around to the other side. This is the charger, this is the inverter, and then this is the motor and transmission, or the gear reduction. I'm going to take the battery, to reduce the height of the whole unit, I'm going to take the charger off and relocate that when I put it in the Ranger. Then my motor height will only be this high and it'll fit under the seat. Some points again of that are important. This is the PDM, which is a whole bunch of wires the Resolve controller gets hooked into. Then there's another connection with the inverter. It's called the inverter plug-in, and that you again tie that into Resolve control and other things, including the water pump. This is a drive axle, so this is gonna on the Ranger, this will drive the front wheels. Okay, so here I've rehooked the hoses up. Here's the water pump, and then I put a T in here, and this goes to the atmosphere so you can fill the system and get the air out of it. And then when I run it, the water pump starts about 10 seconds after you turn the switch on, and then it circulates the water, and then when the system detects the water at like 110 degrees or so, it'll start the fan. This is the normal charge port, and I'm just going to use the normal charge port, not the quick charge port, because I don't think it's necessary for my application. It has a mechanical park feature that's run by electromechanical motor that sits up here. Isaac suggests you take the park thing off because I think it's too complicated to use it the way the Leaf operated it. And he feels a handbrake is adequate. Well, because I live in the mountains, I've decided I need the park feature so that one day the Ranger doesn't get away from me and roll down the mountain. So I've taken off the electric mechanical device, and I'm going to just convert it to a mechanical device, and I'll show you here. Now it's off, now it's on. So it's just a little bit of travel, and I'm planning on hooking up that to a cable and sort of like a handbrake affair with a switch in it, so that this park feature has to be off before it will gauge into drive or reverse or anything like that. Just like you have to have your foot on the brake in order to shift. They'll just tie into that electrical system. Okay, coming around here, here's the battery plus terminal. This is the negative terminal. This is an earth brush, which is really important to retain because what it is just sort of a carbon brush that goes to ground to prevent corrosion or pitting of bearings and gears because of electrical currents that might be stray currents that might be flowing through the mechanical system. This is the Leaf accelerator pedal that Isaac just figured out how to use. This is a 12-volt battery. And then I've hooked up a control panel, sort of mimic your dash. This is the Resolve computer controller for the Resolve EV control that was developed by Isaac in Sweden. This is a Leaf Spy unit that ties in with Bluetooth that allows you to monitor some of the aspects of the battery from your iPhone. And these are the controls. This is the ignition switch. This I mimic the brake switch. So when this flips up, the brake is on. This is push buttons for drive, neutral, or reverse. Then there's a brake light here, a radiator light when the fan comes on, and a water pump. And this is a little LED control panel, tells you where you are with your drive or reverse or whatever you're in. So now I'm going to start this up. So I turn on the ignition switch. The water pump says start water pump, and it'll start shortly. The panel shows the battery's at 71% and I'm in neutral. So now I want to go with drive. I put the brake on, and then I just scroll the drive. And drive, there's 3 positions. Drive 2 has high regeneration. Drive, just plain drive, has basically no regeneration. Drive 1 has sort of medium regeneration. And then, so that's drive, and then there's neutral, and then there's reverse. So I'll put it in drive 1, take my foot off the brake, step on the accelerator, and if you can see the shaft there starting to turn, that's wide open. And I verified the speed using a strobe light app from my phone, and it's right on. So now, that was the regular drive. Now I'll show you the drive 2 and regeneration. Turn off the brake. See how quick it stopped? So you can imagine the regeneration there. Put the brake on again, put it in reverse. Take the brake off. Now it's in reverse. And reverse speed isn't as fast as the forward speed because you wouldn't want to go wide open in reverse. So that's the controller. It works. I'm satisfied. It's going to work in the Ranger. I just now mechanically have to install it and modify the battery packs so that it all fits underneath the Ranger. If you have too much torque, like my application, I'm gearing down the motor so much, or the gear train so much, that I'm concerned I might have too much torque. Isaac says he can take and give me a software update that will reduce the torque but not the speed. So if I need to do that, I know Isaac can do that for me. Now Isaac has been really great to work with. He's been very helpful, and I think he's created a great product that will allow us to use the Leaf drivetrain simply and easily in an electric vehicle conversion. Thank you.